All right, long time no see. Hi. All right, so let's get started. Hello, I'm going to repeat this because probably half of the people didn't see it. So I'm Marco, I'm a Kramis on the internet. If you meet me on the internet already, you probably already hate me. But if you meet me in real life, maybe I'm a bit more an acceptable person. That's my avatar. I work for a company called Rove. We are consultants. So if you have money to give me, just call me. I'm just kidding. Work on Zen Framework and on Doctrine. Doctrine project. Doctrine project is a set of persistence-oriented libraries for PHP. I have to repeat that because we are going to talk about the ORM specifically, not just about Doctrine. You're looking for people that can come and help us. Mostly we review merges and handling of the entire release process. So please come and talk to me if you think that you want to help out and you know what to do. It must be somebody that is able to say no a lot of times. It's not about merging a lot of stuff, it's about saying no more times than actually merging stuff. I'm sorry, that's what it drills down to. So we're talking about Doctrine ORM. I have to mention this because of license things, but Doctrine ORM is a JSR 317 / Hibernate inspired mapper system. Even though I have to mention it, actually the people at Hibernate and EclipseLink and all these people, they actually know what they're doing. We always joke about Java developers, but geez, these people had it 15 years before we got there, okay? So they know what they're doing. And we're pretty much just copycats, but still, we're trying hard. So this is about Doctrine to best practices. And these are my best practices, not necessarily yours. So don't take what I say as law. These are my opinions, make your own opinions, but this is what I prefer. All right, so first of all, you need to know your enemy. Your enemy is your tool chain. Because once you require something as a dependency, it is your problem. Okay, it's not like somebody else will fix it for you and solve all your problems and save you from doom. Once it is in your vendor directory, it's yours. Unless you paid for it. But you probably didn't anyway. So, first thing, this is not an icon. I got told that this actually means manual. Please read it. I didn't. My mistake. Please read it because knowledge is power. Now, not everyone agrees with it, but I'm fairly sure that as developers, learning stuff is actually really the starting point. Don't start and use this ORM without having understood what it does in depth, because it's kind of a magic box. It works fine for some scenarios, it is absolutely terrible for others, like any tool. So, when is the ORM an appropriate tool? An ORM is very well suited for some specific kind of problems, and these problems are what we call OLTP. Online transaction processing. Online transaction processing means start a transaction, do a shopping cart checkout, commit. This is what an online transaction is. An online transaction is not upload 4 gigabytes of data, process it, and then you just get a response. This is not what the ORM does. Okay, so online transaction processing is about small, isolated business transaction. It is about DDD. This is a bit of a lie, because you can't do full DDD with the ORM. It still has some limitations, but it allows you to do a lot of the stuff that you learn in domain-driven development. So it gets you very far when it comes to designing clean business domains that follow your domain rules. It's about fast prototyping. So you don't get from somewhere in the other department of your company a schema definition that was written 2 years ago and you will have to implement your application on top of it. No, you change the schema every day and you don't need to get it through 10 layers of DBAs to get it approved. Okay, so it's about getting it fast, rewriting entities, changing things really fast. We're talking about object-oriented first. So if you're a functional programmer, this is probably not a good tool for you, because it's about juggling state. It's really just a juggling state thing. It moves state around. All right. Who is it not for? And this is really, really important because what I get online is a lot of hate for ORMs by people that do use it in the wrong context. It is not for dynamic data structures, like a field that can be a string, a boolean, an integer, or your mama, whatever. Means really huge. But anyway, don't use it for that stuff. It's not for reporting. Reporting is what we call OLAP, online application, can't remember, whatever. Anyway, reporting works really fine with this amazing technology, which I hear is getting more and more popular. It has been developed a lot, and it's getting really, really stable. All the hipsters use it, and it's called SQL. Okay, this is what you use for reporting. It's a language designed for doing reporting. It's a query language after all. So if you have to do your report where you aggregate 10,000 million data, put them in another table, then crunch it again, then do another million records computation, whatever, then don't use the ORM. You're just doing a suicide there for your servers. Servers doing harakiri. But, so where do we start? Let's do some more practical stuff. Where do we start? The ORM starts from designing entities. Entities, of course. We are talking about the base components of your system when it comes to the domain. In theory, you should start from value objects only. If you were to the other talk, you know what a value object is. But in general, in a business domain, you have this concept of entity. An entity, by definition, is an object that has some stuff in it, does something, and it has an ID that is assigned. And this ID is not the memory address space location. So it's not identified by its position in the memory, but it has an assigned identifier, auto-incremental ID, string, whatever. That is what an entity is. So entities, first of all, should work without the ORM. So when you design your system, you can start and design your system to use only file get contents, file put contents, serialize and unserialize. If you can design your entire system with these functions without using the ORM, then you're quite okay. Okay? All right. So entities should work even without the database. The database is just where you store and save this stuff. And the database gives you some constraining at persistence level, but it is not your business logic. The database is a storage. It is designed for a storage, and then people use it for OLAP, which is a different scenario. It's not what we're solving. Entities generally are concepts inside your domain, like a customer, an invoice, an order, and so on, while the database is just saving and loading stuff. Now, if there is a DBA in the room, you're free to throw tomatoes at me. I don't care, but I stand on this one. So first you design the entities. After that, you model the database for those entities so that there is minimal impedance between the database schema and the entities. And the mappings are just something in between. So in general, you can generate the database, but you will always have scenarios where it doesn't fit 100%. And don't go crazy to make it fit 100%. Use database migrations for that. It doesn't need to be always perfect. It needs to fit your schema, kind of. All right, designing entities. So we start with this. This is a user object, has a username, a password, and a getter and setter. Getter and setter, who designs this? Anyone doing this? I do that as well. Yeah. Please stop doing that. Okay? Entities are not typed arrays. If you want typed arrays, then use PDL. And use the row database adapter, and you don't have your domain logic, and maybe you store it in the database, you SQL triggers, and get your job position forever. But entities have a behavior. Entities do things. You talk to a user object, and you say, can I authenticate? Or can I cancel my subscription? Or, I don't know, can I reset my password? So the internal state of an entity is irrelevant. What you need to design is the public-facing API of your entity, because it is an object. In object-oriented programming, things talk to each other. They don't pass around data. Right? So you do the state design later, because the requirements around the state and logging and so on, they will come up. And you will have to redesign your entity for the scenarios where you have to log authentication attempts and stuff like that. All right. If you design state first, what happens is that you will incur in scenarios where the state design that you had locks you into some certain design approaches, and you can't escape them. You will have a lot of coupling there, and it will be really, really hard to escape that. So here's a better approach to the user object. So we have a flag band and this stuff. This is not important. This is not important stuff, okay? But now we have a to nickname, which returns the username, for example. But it may return the first username from a table of aliases, or the last username that the user picked, which is in a collection somewhere. We don't know. It may change over time. It doesn't need to be a property here. Then it has an authentication function where you pass in a password, a check hash function, which is just a hashing algorithm, and you do the authentication there. And you have a change password, which does the hashing, giving a hashing function. You should probably not use callable here, but use instead some interface, but still, this is better than having just state moving around or getting the hash out of the object, passing it around in your system, and then you don't know if this hash gets logged somewhere, and now you have a security issue because your user hashes are in your log files. This is a problem, okay? So, since if you don't have any behavior, you're just storing and loading data, then I have two questions. One, why the heck are you building this? What is the point? Why don't you use Excel? I'm serious, just use Google Spreadsheets. You can probably build the same application you're building with Google Spreadsheets. And second, you don't need ORM. Just use any persistence layer you want. You don't need Doctrine for this. Okay, Doctrine makes it nice, but you're still just abusing it. So, other things you should do, respecting the Law of Demeter. Anybody does not know what the Law of Demeter is? It's okay if you don't know. Right? The Law of Demeter is basically telling you that you have to talk only to your neighbors and not to your neighbors' neighbors. Now, there is this game that children play, and it's called Chinese whispers. So you say a word to the first person, and the first person says it to the second, and the second person says it to the third, and so on. And 30 children talk about it, and you say snake, and it comes out as lion. Okay? You all did this, right? This means that somebody in between is lying, but you will never know who it is. This is what the Demeter law is about. So, here we have a scenario where the Law of Demeter is kind of subtly hidden. The violation is hidden. So what we have is has access to, okay, a user has access to a resource, which is probably a value object as well here, and then we verify whether from the current access levels of the role of this user, one can access the resource. So what we're doing is we're looping over data coming from a neighbor, okay? I'm talking to role, and role is talking to access levels and giving me access levels. So I'm reading data from the role here. This is a violation. So what you do is you get rid of these and you just do one jump. So if your role object is responsible for doing the access check, then do it there. So has access to is just deferred to the role. This means that you can implement different role assignment strategies or multiple roles for a user, but still the responsibility is moved to role. You're moving it to the actual layer, and you're reducing the jumps by one. And this has a lot of advantages. You have more expressive code, because this, to be honest, this is easier to read than this. Okay? I mean, seriously. It is much easier to test. You just pass in a role and check it. You have much less coupling. It's much more flexible because you can add role strategies. And it is much easier to refactor. You have only one endpoint. You don't do these jumps that are like find usages and you find 30,000 usages of this API around your application. So, since we are preventing indirect access to data, we want to also prevent collections to be visible from the outside. Collections are in Doctrine are mutable by design, which is perfectly okay, at least for this kind of applications. But what you should do is you should disallow other objects from modifying them. So this is what happens usually inside form components or in generally most applications that we work with. So you have a user object, you get the buns from the user, which returns a collection, okay? You expose it there, and then you have somewhere in a service layer or whatever, you have a bun user, you get the user ID, and then you find the user, and then you get the buns and add the new bun with the current user. Okay, you create a new bun. And this may be cascade persisted or whatever. The problem here is that you are exposing the collection. And this has a lot of problems. Mostly problems that I was talking about in the previous talk, which are about mutation and encapsulation. But what you can do is you just refactor it so that the user interaction to ban a certain user is just hidden inside the user. It is an interaction now. So my service layer now just simply says user ban. That's it, simple. And if the user cannot be banned because it's a super administrator, you throw an exception. And if the user should be, if the ban should not be ignored because the business rules say so, then you can just code it in here, which is much more flexible. Entity validity. Who uses Symfony form validation? Right? Zen form validation? Yeah? Well, these forms pretty much try to populate an object with some data and then validate it. At least that's what the typical approach is. And to be honest, objects are always supposed to be in a valid state. So entities are supposed to be always valid. You cannot create a user object with an empty username, period. So you don't create the user object and then validate it. That's stupid. You have a broken object now in memory. So now every time you get a user object, you have to check it because you don't know if it's valid or not. And if you try to save it on the database, it will crash. 20 service layers later, it will crash, which is a problem. So any invalid state should be pushed to a separate object. This is a typical scenario where you have multi-step forms. Okay, so you have a form where you first enter the username, then you have a second page where you enter your email address, and then 3 pages where you enter all your credit cards, right? Because you trust them. Right, so you just push them to separate objects. So what you do is you use something called a data transfer object, which is just a stupid struct-alike object. It can even have public properties, but at least you know that you do not trust this object. You will have to validate it. But it is not the entity. You're not creating an entity with invalid data. And this applies to any kind of temporary state that you're not sure about. After construct, you stay valid. Any transition of state that would make your object invalid should cause an exception and a rollback of the state. Regardless of the database is not a problem. So this is really problematic though, so you may end up having a lot of named constructors. Named constructors are okay. They're basically public static function, create from this and this and that. Public static function from database, public static function from serialized state, public static function from user input. And these create your object. So you make your constructor private and use these instead. You get rid of setters. This is repeated from the previous talk. But basically, setters are just state moving from one object to the other, and there is no verification. And a lot of people writing stuff with APIs and so on, they use a serializer that just calls setters and getters and populates these objects without checking anything. This is a problem, and it will bring security issues. I had multi-million pounds projects, which probably don't cost that much anymore since the Brexit. But I had a multi-million pounds project that failed because the security requirements weren't met because it was all done via serialization. We are getters and setters. So, other things you should avoid. Entities are concepts inside your domain. Anything that is in an inner layer cannot depend on code on the outer layers. Instead, the outer layers can depend on the inside layers. This is basic hexagonal design, but basically anything that is framework and HTTP and so on is not part of your user object or your invoice object. You do not require an HTTP request inside a user object. So what you should avoid is having any kind of coupling, static coupling, or hidden coupling between these two. Okay? From the outside in, it's okay. From the inside out, it's not okay to have this coupling. So you have a user controller and you have a register action. This happens very often. Then you have a user form bind. You create a new user. Not good. What happens here is that the form knows how to interact with the user object and is some kind of framework. And the next time you do a composer update, everything crashes because they changed some rule about how getters and setters work. Now, this should not happen, but it will happen. You can't avoid it. It will break sometime because people make mistakes. Here we have a better approach. So now we have a entity manager persist user from form data with the form. This is also coupling. It's a bit better than the previous one because now our user object has control over how the form works instead of the opposite. But still, our user object now has a type hint against the form system, and the form system is just garbage in the front end. Okay, so you should just pass in the data here. Raw data or raw value objects. For components, pretty much break this entity validity stuff because they move data around and it's invalid and they don't care. So both Symfony form and Zen form are absolutely terrible at this. So what you should do is just use arrays coming from the data from the forms. I don't know about Laravel. I really don't know about it, but I assume that it's probably going to be the same stuff because this is how form components usually work. So for this use case, don't use them. If you bind them to the database data transfer object, then it's fine. You just create this data transfer object, bind to that, and that is okay. You can do that. Get rid of lifecycle callbacks. Who uses lifecycle callbacks? I use them as well. Yeah, more hands. The more I watch, the more hands come up. Lifecycle callbacks are a persistence hack. Specifically, what a lifecycle callback is, it is pretty much serialized and unserialized, but ORM specific. Okay? Now, think about this scenario. You have a user object that every time it gets serialized, sends out an email to somebody. Does that make sense? Or when you unserialize an object, you create a database connection and log something. You don't want to have that. That is really complicated to debug and understand. So please don't do stuff that is not just internal state mutation inside serialize and unserialize. Things like last modified are kind of okay, but more than that is usually a problem. So don't use lifecycle callbacks for anything that is business logic because you will have bugs because you're just pushing data around. You're not expecting business logic to be executed. You're just saving and moving data around. Right, let's get rid of auto-incremental IDs. So, auto-increment, I use it. Everyone uses it, right? I don't want to see hands down. All right, anyway. When you create a user object, does it have an ID? No, right? So it's broken. It doesn't have an ID. It's an entity. It's supposed to have an ID. Why doesn't it have an ID? So this means that now you have a problem because you have this object and you can't do anything until you save it on the database, which means that any operation that relies on this object needs this object to be first saved in the database. So database operations will have to be executed in a certain order, which depends on foreign key integrity, of course, but you will have this issue there. You are blocking bulk inserts. You can't do bulk inserts because in a bulk inserts, you need to get all the identifiers of all the inserts that happened in the right order. And this is going to be a problem. And you can't do multi-request transactions. So you create your user object, push it to a temporary storage, or just the state of it, and recreate it on the other side, but the ID is missing. So you can't do much about it. You have no way of identifying this user. And the object is basically invalid until you saved it. But the object should exist without the database and without the ORM. It doesn't need it. So, your object does not work without the database. This is kind of broken, right? What did I do here? Right. So, instead, there is a very simple solution, which is to use UUIDs. So UUIDs are just very large integer numbers, and it's a random ID. Now, to give you an idea of how random this number is so big and so random that it is more probable that our planet is hit by an asteroid than you having a collision. Now, if an asteroid hits our planet, we got bigger problems. okay? Your data center is not my problem then. You probably want to run away or something. It's really easy to use UUIDs. You just put it in a constructor. Since it's an entity, it has this constraint, it has to have a UUID. And instead of getting the auto increment for sorting, you just put in a date time or something like that. So use a datetime field, use a microseconds field, whatever you want. But use that for sorting. Other things that are useless, at least in ORM context, are derived primary keys, where your primary key is the primary key of an associated entity. This is just messy. It doesn't help you in your domain. Maybe the other object is a value object then. Or maybe you have a design issue in your domain, but usually you do not need to design this. You just are normalizing for the sake of normalizing, because you read in a book that third normal form is nice and DBAs like it. Now, I know that I'm saying DBAs a lot, and it sounds in a negative note, but seriously, these people save our ass every time that a database goes down, production goes down, and so on. So please be thankful for what they do. But they have their fixations, because they work on databases all day. And these are normal fetishisms for them, okay? I like normalization. This is normal for them. Haha. Anyway. Does your domain really need a derived primary key? No. If it's not part of your domain, then you don't need it. Very simple. Same for composite primary keys. Instead of making a composite primary key, just use a surrogate identifier with a UUID and then make a unique constraint on the other fields. And anyway, when you have a duplicate key, you will have to do some validation at service layer anyway. Right? So just, again, does it make a difference in your domain to have a composite primary key or not? Or is it just a data issue? Right? You want to also favor immutable entities. You want to pretty much create entities and never modify them, because this allows you to do a lot of stuff with the data that you create. So this means creating append-only data structures. Here is a scenario that is really useful. Now let's say that you are building a forum software with bulletin. Yeah, so you're creating this append data structure for when a message was read. So you have a private message, it has a from, a to, a message, and then a list of who read it. And whenever you say read, you pass in the user and you create a new message read with the user that read it. And on the other side, you just have a message read, which just has a constructor. It doesn't do anything else, which means that this object will never change. It's an insert-only table. So I'm not going to go into detail about this, but immutable data is very simple to reason about. You keep appending. Some queries are worse with it. Some queries are quite okay with it. But it is cacheable. You can cache it because you're only appending. Any past data, you just make a direct hit against a cache. You don't need to hit your database about it. You can do predictions about how it's growing and so on. And you can do analytics. Right? For example, in this scenario, you can do a security analysis, like why did this person read this private message and how did he get in? This is one example of what you can do. There is a bigger thing that you can look at. This is called event sourcing. I'm going to talk about it tomorrow. There's a workshop about it. So if you want to join, just, I think, ask at the reception. But anyway, event sourcing is pretty much taking this and bringing it to the extreme. Other things that should die in a fire. Soft deletes. Anybody using the Doctrine extension soft deletes? Yeah? Yeah. Because you don't throw away anything. You know, in the medical context, not throwing away anything ever is considered a sickness. Right? We developers are asked to do it. But anyway, soft deletes are a broken idea. Soft deletes are a broken idea. It comes from a world where everything has to sit in a single database and your logs are not really authoritative and so on and so forth. But soft deletes, in general, you have everything in a single database and you want to keep it there. So they have some problems. First of all, they break immutability. This means that now your objects are not being deleted, they are being mutated to a state from existing to flagged as deleted. So you're modifying data, you're not deleting it. Second, you're breaking data integrity. Now you have half the database is valid, the other half is deleted data. But you still have foreign key from the valid to the invalid data. How does that work? Every time we will have a query that crosses this boundary between valid and deleted data, you will have a crash, because that's how soft deletes work. Now, usually this means that there is a domain concept hidden below about deletion. I had a customer that built big machinery. You can imagine that a machine was as big as this room. They printed metal pieces, okay? And then what happened is that after 6-7 months of building metal pieces, they just delete the machine. No, you're not deleting it. Like, what does it do? Poof, and it disappears? It's not like that. You dismantle it, you put it in boxes, and put it somewhere else. Because they will eventually grab it later and rebuild it somewhere else and reprint the same pieces after they need them. So, this is a domain concept that is very different. So you're getting rid of the idea of deleting, you're archiving, or you're moving to an inventory, or stuff like that. But you're not deleting the data. This is what usually happens with soft deletes. So this means that there is a business rule that nobody's telling you, and you need to find it out. That's what usually happens. For security audit, just use a log. Okay, don't put soft deletes as a security problem. Mapping drivers. All right, this is really quick. For your private stuff, it's perfectly okay to use the annotation driver. You get it done quickly, it's fine. At the end of the day, they pay you to build software, not to look at software and make it nice and shiny. Okay, it needs to do something. It doesn't need to look cool, it needs to work. So, for public stuff that you want to publish, please use the XML mapping drivers. Right? And do not use YAML, please. Okay? It's useless. It's absolutely useless. And we constantly get poked about YAML and validity and so on and so forth. XML, you can just validate it, has autocomplete, whatever. But the point is that since the mappings are separated from the entity, if you require a public package that has mapping definitions for the ORM, you can easily replace the mappings, which is the entire point of this. Lazy or eager loading. Now, by default, the ORM uses lazy loading. What I see in companies is that a lot of people put eager loading everywhere because they think that the ORM will do everything magically. Now, eager loading is basically useless because while it works 1-2 times, in all other scenarios, it causes the typical n+1 query problem. So be very careful about when you use eager loading. It's usually not what you're looking for. What you want is maybe a fetch join and stuff like that. On the other side, we have extra lazy. When you have extra lazy in a mapping, that usually means that you're reaching the limits of what the ORM can do. Because when you have an extra lazy collection, that collection may be huge. So when you load it in memory, then you make your application crash because you run out of memory. So this is where we get to the limits of what the ORM can do, and you have a lot of transaction and performance problems. You have large serialized transactions, large units of work, and generally problems with the performance of your application. Get rid of bidirectional associations. Try to make them all unidirectional. If you have a one-to-many, you can do it a many-to-many one-directional. It helps. Keep it just to what your domain needs, because bidirectional associations are a lot of overhead, but generally you need to consider when do these objects need to know each other from a domain perspective. Do they need to know each other, or does one need to know about the other? Think about that when designing. Not about how you want it on the database, but how you want it in the domain. And if you need a bidirectional association just for one query, just make a complex DQL query for once, but don't code a bidirectional association for laziness, because it is a lot of coupling. All right. Other things I suggest, use custom repositories for your stuff. Repositories are supposed to be part of your domain. It's a collection of things, and they add a lot of expressiveness and understanding about what you're finding and how. So here's an example. You have a user repository. You see that it doesn't extend from anything. It should implement an interface from your domain here, but it doesn't extend the Doctrine repository stuff. Okay, so what you can do is then you have a find users that have a monthly subscription. This is clear and understandable. You use underscores, whatever you want, but this is very clear and understandable. There is a secondary approach, which is, I think, even better, which is having some query functions. Basically, what I do is, well, you see that we have these find users that have a monthly subscription, right? And what you do is you move it here. Users that have a monthly subscription. It works as a function, returns a traversable. Simple, right? So now you open a directory and you know exactly which functions are available inside your domain. All right, repositories are services, so please treat them as such because they have shared state. And the same it goes for query functions. They are bound to the current connection, so you can't just pass them around randomly. So avoid using stuff like the object manager get repository, because get repository is a service locator. And the service locator comes with a lot of disadvantages that are well known. I'm not going to talk about it, but this is coming with a lot of problems. So define a service for your repositories and then inject your repositories inside the other services as dependency. Right. You can also separate repository get and repository find. This is something I really like. So repository find can return null. Repository get cannot. And this is really simple to implement. If it doesn't find anything, you just throw an exception. And then this means that every upper layer can simply rely on this exception to be thrown instead of checking for value being returned. All right? And then you upcast it to a 404 response code inside your application layer. All right, we're almost at the end, probably going over a couple minutes, sorry. Keep transactions unrelated. When you have different services acting on different boundaries, either use different entity managers or clear and between every flush. So you avoid having repeated state. This is a lot of overhead, but since Doctrine 2.5, you have a component called the second level cache, which mitigates this a lot. Different boundaries means different transactions. If you have an invoicing system and a shipment system, they want to act in different transactions. The invoicing system wants to produce an invoice, even if the shipping system fails to prepare a shipment. Okay? You don't want them to fail differently there. Or maybe one brings down the other while API calls were done to external systems. This is a problem. So keep the transaction boundaries inside the bounded context that deal with your system. Across boundaries, instead of passing around a user object, you pass around the user ID or the username. Don't pass around the user object itself. All right, last one. Keep normalization under control. You do not need to normalize everything. All right, keep normalization freaks under control, especially those that just came out of university. All right, if you're fresh from university, you will have this feeling that you need to normalize. So you may need to gag your DBAs, but seriously, DBAs are useful, so please eventually get them to just understand your needs, come to a middle ground. But yeah, in generally, academic knowledge really is distant from practical knowledge on this stuff. You're not building the next Facebook, you're not building the next Pokemon Go. If you are, then you're probably not using the ORM anyway, okay? All right, what about performance? There's another talk about it. You will need to know about the ORM internals, but we're skipping on those. There is another talk about that. You need to profile though. There are tools about that. We don't really care about that here. But measuring is the only way to do that. So let's recap. Domain first. First, write code that fits your business scenario as entities. Do not normalize stuff if there is no need for doing that. Generating IDs on the client of the database is better, for example. Right? You're only digging your own grave if you normalize too much because you are reducing flexibility of your system. And please consider using databases for reporting and database for transactional applications. An OLTP application and an OLAP application do not need to share the same database. You do not need to run the same queries on one giant database. It's a big mess. Right? Transactional data is not your reporting data. Thank you very much. So I don't think we have time, or do we?
Any questions?
Hi, Marco.
Yeah.
I'm listen, maybe not all about what you talk, but you said need put all collection inside entity. Not very good to publish collection outside. But what need to do in situation when you have a lot operation with lists? You need, for example, compare lists. You need to do some operations what you can put inside entity. Can you use public collection for some services for put logic outside?
Yeah, you can do that as long as your collection does not get modified by the external service. So what you need to do is dereference it. So you just make a copy that is read-only. That's what you do. And then any operation that is a write, you push it back to the entity. And the entity is responsible for doing that because the entity is the owner of that collection. Right.
Okay, thank you.
Hi again, Marco. I'm a bit confused about not using normalization. Could you please give us kind of an example where not using normalization is better than using normalization?
Yes. So one example that I had is what we were working on is tracking cars along the road. So now what happens is that a car can be repainted, the car sign can change, and stuff like that. Okay. Now what happened is that in this system we had the object car, okay, and then we had different point in time at which we made a fine for that car. So in 2015 and in 2016, and it references the same car, but that data doesn't really fit well in normalization because that car changes over time. So you're now referencing the same car from a fine, while it is a different car. It is, yes, it has the same ID, but the data around it changed. So if you try to put this in a normalization problem, it becomes really complicated. You're starting to normalize inversion and everything becomes really complicated. Instead, just copy the data over, make it denormalized. It's much better, much simpler, right? Yep.
Hi, Marco. What can you say about using single table inheritance in Doctrine?
Don't. No, you have to use it sometimes, and it's fine. It's just it will not be performant because in a single table inheritance you will always have joins between. Well, you will always have eager loading for an inheritance. Any inheritance, you will have eager loads because anything that references the root of the inheritance, when you load it, you need to know what it is by looking at the column, and you can't really avoid that. You can't create what is called a proxy, which is a more internal component of the ORM. So you don't know which proxy you need, and the ORM is forced to do a query there and do a lookup. So there is a performance issue there. It is good for some problems. I mean, if you can design without inheritance in your domain, that's the best solution. But if your domain just has inheritance, then just use it. You will have a performance problem, but that's it.
Thank you for great speech, and I still can't understand what is the best way to express in terms of architecture, like task like we need to send an email to user and mark that email was sent.
Yes. What you do is you just create additional entries in a table rather than updating a flag and stuff like that. That is what is the best approach usually to those systems. So you basically store information about what happened rather than storing flags. This is what happens when you have 2 times the same email and then a transaction fails, or the opposite. You have a commit and then the email sending fails, and chicken egg.
But where I should put code which actually sends an email and marks?
This is usually the service layer. It should be, what you do is you have a public function on your entity, on the entity, okay? Notify user of confirmed subscription, okay? Or notify of confirmed subscription, because we are already on the user object. And you pass in the notification service as a parameter. In this way, your entity is able to do the interaction with the external scope, but you don't inject the service. You don't make the service a dependency of the entity. You just pass it to that particular method. And in this way, your entity is still responsible for the integrity of the operation, but it doesn't have the external context. The external context is passed in only for that interaction.
I have one question about injecting services inside of entity. Is it a good idea or not?
No.
Why not, if it is?
It is not a good idea because an entity has a different life cycle from the service. Your service exists or ceases to exist depending on request data or session data and so on. But your user object has a different life cycle. So this is the more, I would say, theoretical reason too. There are other reasons that are more technical, such as segregation and coupling and so on. But the biggest reason is that your database connection is not, has not the same life of your user. They're different things, okay? All right, that's it. Thank you very much.
Thank you very much, Marco.